Hi, good morning. Today we are going to look at chapter 6, angles and tangents properties of circles. But today we will look at the properties of angles in the circles. Okay, the first property is angle subtended at the circumference by the same arc are equal. Okay, angle subtended means angle appearing on the circumferences are same if they are produced from the same arc. Can you see? The arc starts from A, ends at B. This is called minor arc, right? You'll have learned that, right? So if you produce a line from A touching the circumference coming to B, and then another line also same starting from A ending at B, and another line, you can put any number of lines creating angles on the circumference. The angles would be same if they are produced by the same arc. See, they start at A, ends at B, right? Therefore, the angles are same. Okay. Another example, take a look at this one. The arc is PQ, right? So, let's say this line starts from here, going here and ending at Q, and this next one starting at P, touching the circumference here, ending at Q, and the third one starting here, ending touching the circumference, going to Q, and the last one starting from P and ending at Q. When it's like that, all the angles created on the circumference would be same. Can you see that? If this is B, this is going to be B, all same. So that's the first property here, right? So angle subtended on the circumference of the circle would be same if they are produced by the same arc, right? Now let's look further on this. Can you see the arc is ST? So I've done some angles A, B, C, D, E. Notice I've colored with black and red. Only the red, okay, are equal. Because why? They start at S, end at T. Take a look at it. S going up to B, coming to T, right? Look at E, starting at S, going and touching circumference, coming to T. So angle B and angle E are same. A is not same because the starting point is not at S. Okay, so A is not. Now, for what about C? It starts at S and ends at T, but it is outside the circumference of the circle. Therefore, it is not same. What about D? It starts at S, ends at T, but it is not touching the circumference. It is inside the circumference. So, it is also not equal. So, you must understand, it must start from the same arc, from point S here, ending at point T, and must touch the circumference of the circle. Then only it is equal. So, can you see the first property? Right, good. Let's move on to the second property here. Okay, the second one says, right, angles subtended by arcs of the same length, okay, at the circumference are equal. Okay, got two parts. Let's look at the first part. That means the arc is different. Can you see this arc is A to B, right? And producing angle A at the circumference. And there's another arc PQ, okay, producing angle at the other side. Okay, but both are same. Why? Because the arc length is same. A to B is 5 cm and P to Q is 5 cm. Therefore, the angle produced on the circumference by both arcs will be the same. Okay, right. Let's look at another one. Right, look at arc length CD is 10 cm. Look at arc length CE 10 cm. Therefore, if you look at this arc length, starting from C, touching the circumference and going back to D, so angle B is created. And then look at this one, starting at C, ending at D and coming back to E. Okay, since both arcs are 10 cm, therefore angle B here and angle B here same. This angle and this angle would be same, right? Okay, let's look further. Now, also another property, angle subtended by arcs of the same length at the center would also be equal, right? So the angle at the center would be equal if the arc length is same. Let's say AB is same length with BC, therefore angle produced at the center would be same. So this is Y and this is Y, because AB is equal to BC. Okay, take note, arc AB is equal to arc BC. Therefore, angle Y and here angle Y, they are both same. Right. Let's look at this one. Right. Arc LM is this one. Arc NP is this one. Since they are both same length, therefore, angle produced at the center would be same. Q and Q. Can follow? So, this is the second property we have learned. Right. Let's look at the third one. Okay, I guess so far you can understand, quite easy, right? Let's look at the third property. Angle subtended at the center by an arc is double the size of the angle subtended by the same arc at the circumference of the circle. Simply said, if two angles are produced, one at the center, one on the circumference, okay, by the same arc, right? Then you must know angle at the center is double that of the angle at the circumference. You can see from A it touches the circumference coming to B, and this arc, right, AB is also same for the center one. See, starting at A, going to the center O, coming back to B. If this is the case, angle at the center would be double that of angle at the circumference. If this is 50, this would be 25. If this is 60, this would be 30. If this is 40, this would be 80. Right. Same way. Right. I produce, let's look at this arc length PQ. So angle at center, can you see, it's 80. And from the same arc from P going to Q but touching the circumference, this would be half of angle at the center. If this is 80, this is going to be 40. Can you see that? Right, very good. Now, another way to look at angle at center and circumference is this way. Okay, for this, take a look at this, right? A, B, C, O. O is the center. So, angle produced on the circumference B is half of the angle produced at the center. That means, angle at center is twice angle at the circumference. This is also true, right? So, this is 2B, this will be B. Take a look at this one, right? Angle at the center is 220, therefore, angle on the circumference is 110, half of this. Can you see that, right? Okay, take a look at this one, combining the top and the bottom is produced this one, right? So, can you see the color difference? This is red, this is red. So, if this is 30, this is going to be 60. Now, when this is 60, you know this is a whole circle, so this is going to be 300. If this is 300, angle on the circumference below is going to be half of that, 150. Now, just remember, if any one of this angle is given, you can find out rest of the angles because of the property, right? Angle at the center is double that of the angle on the circumference. Can you see? For the red and also for the black. Take a look at it. Right. So far, I think you can understand. No problem. Right. If you don't understand, you have to watch the video again. Right. Let's continue. Property 4. Right. Angle subtended at the circumference in a semicircle from the same arc is 90. Okay. Angle subtended at the circumference in a semicircle, say semicircle, right, from the same arc is 90 degrees. Now, for this property, always remember, you must have the diameter as the hypotenuse. Can you see? in triangle ABC, inside this circle, AB would be the diameter because passing through O, isn't it? And the third vertex is touching the C, is touching the circumference. This is going to be 90 degrees. So whenever you see a triangle, right, where AB or PQ or anything is the diameter, which is the hypotenuse, the angle created on the circumference is going to be 90 degrees. Okay? They won't say it's 90, but you must know it's 90. Take a look at this one. Right. Now PQ in this circle is the diameter. Can you see numerous triangles here? So this one is PQS, where this is going to be 90. This is going to be PUQ, where U is 90. This is going to be PTQ, where T is 90. This is going to be PRQ. Can you see this triangle? Right? R is 90. So all triangles where the PQ or the AB is the hypotenuse, the angle created on the circumference is 90 degrees. Okay, can remember? Right. Okay. Now the fifth concept is concept of cyclic quadrilaterals. Now quadrilateral means four-sided polygon, right? Cyclic quadrilateral means a quadrilateral created inside a circle whereby all four vertices will touch the circumference of this circle. Can you see now? A, B, C, D, four vertices touching the circumference of the circle. Okay, this is known as cyclic quadrilateral, right? So what is the property here? Very simple. Can you see the red and red here, black and black here? That means, now you must know quadrilateral is 360 degrees. Okay, but very simple logic here is A facing B, C here, right? The A plus C is 180 degrees. Likewise, angle B plus D will give you 180 degrees, opposite to each other. Can you see that? Facing each other or opposite to each other. Okay, right. If one angle is given, you can find the other angle, right? Take a look at this one. This is also cyclic quadrilateral. The property you must see first. Must have four sides, 1, 2, 3, 4, and all four vertices must touch the circumference of the circle. So P, Q, R, S is touching. Now which the sum gives you 180. Take a look at this. B is opposite to D, so B plus D is 180. A is opposite to C, so A plus C is 180. Can you see that? Right, very simple. This is called cyclic quadrilateral, where the sum of opposite angles are 180. Can you see that? Okay, very good. Okay, now the last part of cyclic quadrilateral, okay, is this. The exterior angle and the corresponding interior opposite of a cyclic quadrilateral is same, right? The exterior angle and the corresponding interior opposite angle, interior opposite angle, right? Interior opposite angle of a cyclic quadrilateral is the same. To understand, take a look at the cyclic quadrilateral. A, B, C, D. Now what I did is I extended the lines here and here, right? So angle, we know angle A plus C is 180 and B plus D is 180. Now when we extend this line, you'll get another angle here as E, right? I put this extend here, this is F. I extend the line here, this is going to be G. Extend here, I'm going to get H. Now the property is like this. If this is A, the angle opposite exterior is also equal to A. So the A will be equal to E. If this is 95, E is going to be 95. Right? D is going to be equal to H. Right? C is going to be equal to G. And F is going to be equal to B. See, A equals to E, B equals to F, C equals to G, and D equals to H. Okay, take a look at this one to understand the property. Let's say if this is 85, this is 95, gives you 180. But this 85 over here, since it's a straight line, 180 minus 95, this is 85. The same thing, this is 87, this is 93 to give you 180. But 180 minus 93 gives you 87. So this is 87, interior opposite 87. Can you see the connection? Right, same way. If this is 93, this is going to be 93. If this is 95, this is going to be 95. This is cyclic quadrilateral properties. Exterior and interior opposite angles are same. Right? Okay, we are done for the angle properties of circles today. Right? You can do the worksheet after this.